All right, so let's get started. So what you will do for this question?
Do I have to look for rise over run? I mean, I don't know what I'm looking at this question.
Okay. So first of all, let's try to have a little bit of clearance in linear equations. So I'll be trying to write something here. See, when you're having, when you want to detect a point or locate a point or an insect or anything in a two-dimensional system, then what you need is you need two, what you can say, lines. You need the horizontal line, you need the vertical line to accurately reach that point. For example, on your, the wall. If you're having wall and you're having, the point in the in the corner, then in that corner, when you start from the corner, if you say that this corner is 0 comma 0, that means it's like, I'm horizontally not moving to the right, neither I'm moving to the left. In the same way, I'm neither not nor moving to the up, neither I'm moving down. I'm just at the corner. And then if I'm telling you, okay, bro, what you have to do is you have to start from the point or corner and then move 3 units to the right. One, two, three. But when you'll reach there, the insect will not be there because it is on the wall, for example, at this point. So what I'll be telling you, okay, you have to move 3 units to the right, and then let's move 4 units up. One, two, three, four. So I can say that the coordinates of this point, the address of this point, as we use the address for our offices or home or anything. In the same way, the point is also having the address, and that is 3 comma 4 for this point. That means you're starting horizontally from the origin, 3 units to the right, 4 units up. You have reached to that point where I told you to reach. So the address is 3 comma 4. So always and always and always, the first point will be the x coordinate, will be the horizontal movement. And the second point will always be the vertical movement. Okay, and these 2 points will tell you where the point is lying on the two-dimensional system. Now if I'm having a point here on the left side of it, so what I'll be doing is I'm starting from the origin. I'm not moving to the right now, I'm moving to the left. So right, I'm having positive numbers, but on the left, I'm having negative, number line. So it's the same thing. 1, 2, 3, 4, 5, but it's negative 5. So my x coordinate is negative 5. Okay, and then going up. So up is positive in the number line, which is vertical. There's a horizontal number line, there's a vertical number line. So you're going up vertically. 1, 2, 3. Let's take it 3. So you're having negative 5, 3 as one more point on the number on this Cartesian coordinate system, or you can say two-dimensional system. In the same way, you're having a point here. It'll be having negative value of the x-axis and the negative value of the y also because you're going down. Are you clear in this? And
Yeah.
also, what about this point here? What will be the x value? Will it be positive or negative?
The x value will be positive,
And what about the y value?
negative.
Good. So we are having, these four coordinates, these four, places, like the first, second, third, and fourth. So this is one thing, this is about the points. Now let's talk about, those points, all those points which are like this, this point, this, and horizontal here, everywhere. So in these points, if I'll be having the y value as, let's take it 4, and the x values are different for every point. See? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. So if I'll take the coordinate of this point, it'll be 1 comma 4. If I'll take the coordinate of this point, it'll be like 4 comma 4. If I'll take this point, it'll be like 6 comma 4, 10 comma 4, 12 comma 4. So what is common in all these points?
The y stays the same. Meanwhile, the x keeps on changing.
Exactly, the y stays the same. And what is that y?
4.
So this line, which is a horizontal line, which is crossing the y-axis at 4, which is having all the points as 4, the y value as 4, we say that this line is having an address for y equals 4. This is the equation of this line. Okay, this is not only the answer, when you solve the questions and equations and you're getting an answer. It's not only the answer, it's also giving you a graphical representation of a line. It's a line. And this line is y equals 4. Now if I'll take one more line, which is horizontal, but a little above it, and crossing the y-axis at 10, that means every point is having the y value as 10, but x value gets changed, changing. So what will be the address of this line?
Y equals 10.
Exactly. So all the horizontal lines which are par parallel to the x-axis are having their equations. We can say that now we're talking now equations now. They're having the equations as y equals, whatever the point they are crossing the y-axis. For example, if this is here, it's -5, so y equals -5 is the equation of this line. Are you getting? So
Yeah.
what will be the equation of the last line? For example, it's crossing at -7.
Y equals -7.
Good. So you have now understood what will be the equation of the horizontal lines. Now let's go for the vertical lines quickly. So let's take one line which is vertically here, and it's having the x value as -6. Now, when you check out these points, which coordinate will remain same for all these points?
The x value.
X value will remain same, the y value will get changed because you're going up and down, So let's take it as like 7 comma 6, 6 comma 6, 5 comma 6, 4 comma 6. Oh, sorry. So X value will remain same. So it'll be
6 comma 7, 6 comma 6, 6
negative
comma.
6 comma 7, negative 6 comma 6, negative 6 comma 5, negative 6 comma 4, and so on. So what will be the equation of this line then?
X equals -6.
Amazing. Great. So you have got the equations of the vertical lines also. Any vertical line, you can calculate the equation. So let's take the equation of this line. If it's here having a point of, let's take it as 3. So it'll be the equation of this line.
X equals 3.
Good. X equals 3, x equals -6, x equals something. So whenever you're having an equation, a line in this form, x equals something, then that line will be a vertical line, right? And when you're having equation like this, y equals something, then that line will be
Uh, what?
that line will be
Wait.
vertical or horizontal.
Oh, vertical.
When you're having y equals something,
Hey, isn't that the vertical line?
vertical, don't you have, vertical lines as x equals something here? You see?
Oh,
You remember?
I thought it was like horizontal. Wait.
See, the x is used for the vertical lines. You see why? Because the values of x is remaining same for the vertical lines, you see?
Oh, okay.
That's
Yeah,
why
I get
we're
it.
writing the equation of that vertical line as x equals -6. But when you're having the horizontal lines, the value of y remains the same for the horizontal lines. That's why we'll be writing the y equals something for the horizontal lines. Get getting?
Yeah, I got him.
Okay, so if I'll be telling you there's a line y equals 3, Can you tell me, will it be horizontal or vertical?
It will be horizontal.
It'll be horizontal, and where it'll be crossing the y-axis?
You said, will it be crossing the y-axis?
Yeah,
No.
but it'll be crossing because there you see one, two, three. This is the y-axis, right? The vertical line is the y-axis.
Yeah.
So when you're having y equals 3, doesn't that mean it's horizontal line but crossing at y equals 3?
Yeah, but it won't it just like continue on forever and be a parallel line with the x-axis?
Exactly, it'll be parallel line with the x-axis, 100% right. But it'll be cutting the y-axis also at point equals at 3, right? Y equals 3, right? So we say whenever the line crosses the y-axis, we say that, this point where that line crosses the y-axis, we say it's y-intercept, intercepting, crossing, cutting. So we say it's y-intercept. The 3 is the y-intercept of this line. Now, if you're having a line which is vertical, let's take it like this. It is crossing the x-axis at -8. We say that this point where the line crosses the x-axis, we say that there's a x-intercept. Y-intercept, x-intercept. Got it?
Yeah.
So x-intercept is -8 for this line, and also the equation for this vertical line will be x equals -8. Is that okay till now?
Yeah.
Now going to the next move, that is an important move, and that is when you're having a slanting line, neither the vertical nor the horizontal. It's a slanting line. For example, this one here. And I'm giving you the points here. For example, this is 0, 0. This is 1, 1. This is 2, 2. This is 3, 3, and so on. All the x values are equal to the y values. That means, if I say that the y value is not 0, y value is not 3, y value is not 1, x value is not 0 only, x value is not 3 only. It's not remaining constant. It's getting changed continuously. But it's getting changed in such a way that whatever the y value is, that is equal to x value. You see? Y value is equal to x value. If you take x as 1, then y is also 1. If you take x as 2, then y is also 2. If you take x as 3, then y is also 3. Getting?
Yeah.
So, that then the equation of this line will be y equals x. Got it?
Okay.
Now, if I'll be taking a more slanting line, which is like this, and the points are in such a way, obviously when you're having more slanting line, that means you're rising more as compared to running. That means your vertical movement is more as compared to your horizontal movement. So let's take it as, when you're having the x value as 1, your y value is 2. You're rising more. If your x value is 2, your y value is 4. When your x value is 3, your y value is 6. Or you can say, yeah, 3, 6, and so on. So can you give me the relationship between x and y for this line?
Times 2.
Exactly, y equals times 2x. So this is the equation of the line, which is in red color, y equals 2x. And this 2, you see this 2? This 2 is giving us the idea of how much steepness this line is having. How much rise over run this line is having, and that's why we call it a slope. Slope, steepness, rise over run. Okay, Slope, steepness, rise over run. How much rising you are with respect to running. So you see here, from 0, 0, think about it. How much rise over run we're having here. From 0, 0, you're having, you're rising up 2 units. You see, y is 2. And running how much? For this point, 1, comma 2?
Uh, by 1.
By 1. So your rise is 2 and your run is 1, 2 over 1. That means this is the slope. And that is why it is put in here in front of it, in front of x. So y equals 2x is the equation of this line, right? But this line I can adjust, I can shift it a little above or a little below. I can make it to move a little up here. See? So, oh, okay. Um,
What happened?
I don't know, the screen got a little bit, you know, changed for me. Okay, no problem. So I can still be able to write. Yeah. So when I move this line, when I move this line like this, it's not now crossing the 0, 0. It's crossing this point here, and that's 4. Now the equation of the line will be y equals 2x but plus 4 simply.
Where?
Because when you check out the points now, that we again having rise over run as 2 over 1, because that's exactly the same line which I have shifted 4 units up from 0, 0. I have shifted it up here, but the y value will be a little different now. Let's check out the points here. The points here will be when x will be 1, the y will be 6, because you're already up by 4 units.
Wait, so would the answer to this question be C?
Oh, you're also doing the same thing here. Okay, let's check it out. So your rise or run is, don't you don't need to see the explanation. Let's try to see the question first. So the rise or run is 2 over 2. No, 2 over 3, right?
Um,
Like
yeah,
you're going up 2 units, you're running 3 units, and you're reaching here. You're going up 2 units, you're running 3 units, you're reaching here. So that is why the rise or run is 2 over 3. So
okay,
A can be the answer, B can be the answer, not C, not D, right? Because the rise or run you have to check, not run over rise. You see?
okay.
So the rise over run is 2 over 3, and the line is crossing the y-axis at how much?
2.
0, 1, 2. Exactly, it's crossing it at 2, so it should be having plus 2. So you can have only first option as the answer. But we don't want to have only answer to this. We want to have the answer to all the linear equations, and for that we have to clear our concepts. That's why I was trying to make you understand the horizontal, the vertical, the slanting lines. So whenever you're having the line in this form, y equals 3x plus 4, what does this mean? This 3 means what, and this 4 means what?
The 4 means it crosses at the y axis, and the
That's
3,
called. Hmm.
you're timesing the x by 3, and that's your equation, I think.
Exactly. So the 3 is rise over run. You're going, rise 3 units and running 1 unit. And then 4 is the y-intercept. The y-intercept is where the line is crossing the y-axis. We call this y-intercept as b in general. We call this rise over run as m in general. So we write the equation as y equals mx plus b.
Okay.
And this mx plus b is called the slope intercept form. So what is m?
Rise over run.
Exactly. And what is b?
The y-intercept.
The y-intercept, correct. So in order to calculate rise or run directly, if you know the 2 points of the line, you can do that also. For example, what are the coordinates of this point?
Hold on. 3, 4.
Very good, 3, 4. You can take any other point. Let's take it uh this point here. What are the coordinates of this point?
Ne -3, 0.
Negative 3, 0, correct? So any 2 points you select on the line, you can calculate the slope by using the formula also. Slope is change in the y, that's the rise, change in the y2 minus y1, divided by change in the x values, x2 minus x1. So you can take x1, y1, anything. Here, x1, y1, and here you can take x2, y2. Now, can you plug in the values of x, y2 and y1 in this equation?
Wouldn't it be 4 minus 0 and then
Mm-hmm.
3 minus -3?
3 minus negative 3, right? So 4 minus 0 is 4, divided by, how much is 3 minus negative 3?
Hold on. Wouldn't it just be 0 then?
You're having 3 minus negative 3. Won't that be minus times
Oh,
minus
wait,
plus?
wait. So then 6.
Right, 4 divided by 6. But how much was our slope?
What?
How much was the slope of this line?
What do you mean by how much is the slope of this line?
Haven't we calculated the slope of this line already? Option A. What is the slope of this line? Isn't that 2 over 3?
Yeah.
That's here what we got. 2 times 2 is 4, 2 times 3 is 6, so 2 over 3.
Okay.
So you are getting the slope by using any 2 points on the line and using the formula m equals y2 minus y1 divided by x2 minus x1. So can you write it somewhere? Because you have to use it many places. So
So
if you
what do you want
have
me to put that?
so if you're having the line and the 2 points are given as x1 y1 and x2 y2, then the slope is y2 minus y1 divided by x2 minus x1. So whatever I'm telling you, this is all needed in SAT. So that's why you have to, remember it, or you can just record the sessions. Maybe you can revise the things. You're having an option of recording.
Okay.
All right, so let's clear all this. And any line which you're having can be graphed also on the calculator. You will be given a calculator, okay? The online calculator, which is on the screen. You can go to the College Board website and there's an option of Blue Book. So there you can download that and you can have the calculator, which you can use for graphing the, the equation. For example, you can take TI-84 also with you. And then what you can do is you can go to stat plot, option on the top, second stat plot. Oh, I don't know what it is here. Okay, so you can go to the stat plot. You can go to the, y equals something. So there you can write the equation. Example, I have written the equation as negative 1 over 24x squared plus 4x minus 50. And then what you can do is you can graph it. You can graph it. But this is not the correct equation. So whatever the equation you'll be writing, you'll be graphing it. So let's take it, let's delete it. So you can write y equals, what was the equation? 2 over 3x plus 4,
Yeah.
right?
2 over 3x. Wait, for the last one.
Yeah.
2 over 3x plus 2.
Okay, 2 over 3x. You see x near alpha, like 2 over 3x
Yeah.
plus 2. And then you can graph it. See the line.
Yeah.
And you can directly get the answer by just graphing it.
Okay.
So that's also, one of the ways of doing it. This is the next question, right?
Yeah.
Can you read it first?
In the xy plane, lines L and K are parallel, and the equation of line L is 5x plus 8y equals 32. If line K contains the point negative 5, comma 12, what is the value of y-intercept on line K?
Now we are extending our concepts for the lines. Till now we have understood one line, only one line, all the details about one line. Now, for example, you're having a line, you're having, one of the points as maybe like, x1 comma y1, and you're having one more point as x2 comma y2. So first of all, what you got was you calculated the slope, m equals y2 minus y1 divided by x2 minus x1. And then you analyzed what will be the y-intercept. For example, the y-intercept is something like here. This is the y-intercept, this is b here. And you know that in case of the y-intercept, don't you have the x value 0? For example,
Wait,
when you're having the, yeah, I'll be doing it again. See, for example, the line is here, it's crossing the y-axis at 3. What is the x value there?
0.
Exactly. So, for example, if you know the line y equals 2 over 3x plus 2, and you want to know the y-intercept, then you can plug in the value of x as 0 for that equation. Y equals 2 over 3 times 0 plus 2. Y equals 2 over 3 times 0 is 0 plus 2. Y equals 2. So when x is 0, y is 2, means the y-intercept is 2. Any equation you're given, for example, y equals negative 3x plus 4. What is the y-intercept here?
Wait, hold on. So would you, hold on, would you just plug in that 0 for negative 3x?
You'll be plugging the value of x is 0,
X is 0, I mean.
and then you'll be solving
It
it.
would, it would just be 4.
4. That's why the 4 is written there, but still, you'll be getting the 4 as the y-intercept. That means this line is crossing the y-axis at 4, right?
Okay.
So this is one thing which you have analyzed, the slope, the y-intercept, and now, for example, the question is telling you, I'm having a line y equals 2 over 3x plus 7, and the question is telling you, what is the value of y when x is 3? Again, the same thing as you did for the y-intercept. Okay, when x is 3, plug in the value of x is 3 and get the value of y, right? x, and y. So when you plugged in x as 0, how much you'll be getting y for this equation?
Wait, 7?
7, right? So when x is 0, y is 7. That means the y-intercept is 7, right?
Yeah.
Now when you plug in the value of x is 3, how much will be the value of y?
2?
2 times 2 over 3 times 3, so it'll be 2 plus 7. So when you plug in the value of y, x is 3, so it'll be 2 over 3 times 3 plus 7. Can you solve it? 2 over 3 times 3, because x is 3 now. 2 over 3 times 3. So 3 is on the top, 3 is on the bottom. So it'll be like 3 times 1, 3 times 1. It'll be like 2 plus 7. And that's how much?
It's 9.
Exactly, it's 9. So when x is 3, y is 9. Okay? So you got the 2 points. You got one point as 0, 7. You got another point as 3, 9. Can you confirm what about the slope of this line? Don't you have like x1, y1 given here and x2, y2 given
Yeah.
here? So what will be the
Wait,
slope?
I'm doing it right now.
Okay.
2 over 3.
Right. And that was there at the front. That's what we call the slope, right? So 9
It
minus
says
7.
the
Yeah.
it says the remaining meeting time is a minute. I gotta
How,
go back.
oh, is a minute. So we need to log out and log in again then.
Okay.
So let's log out and log in again.